I'm Phil Coletti, Product Manager for Hybrid Tables here at Snowflake, and I am very excited to let you take a look at what we're working on with Hybrid Tables and Unistore here at Snowflake. What we're going to cover in this session is, first, we're going to do a quick whirlwind tour of the Unistore workload and the Hybrid Tables feature that powers that workload here at Snowflake. I promise we'll try to keep the slides and me talking brief, and then we'll get as quickly as we can into a demo where you'll see Hybrid Tables in action powering a lightweight transactional application for our Tastybytes food truck business. Let's quickly cover what we're doing with Unistore here at Snowflake. Unistore is Snowflake's modern approach to working with transactional and analytical data together in a single data platform. The main value proposition that resonates most with customers about Unistore is the way that it lets them simplify their data architectures. You can reduce the number of database technologies and pipelines that you have to manage because now you get fast point operations directly and natively inside Snowflake. By bringing your transactional data inside Snowflake and having it be born there, you have the ability to build new use cases off it immediately. If you have data that already lives in Snowflake that you need to leverage within an application along with transactional data, you have that data already within Snowflake. And if you need that transactional data for some other adjacent or downstream use cases, that data is ready to query immediately on day one. Last but certainly not least, Unistore is part of a single Snowflake platform. So you get native distribution across all the major clouds. You get consistent data governance and security applied right out of the box centrally without you needing to do or manage anything. Unistore is a foundational workload for Snowflake. And what we mean by that is it's going to be broadly applicable, relatively low in your stack, and also the other higher level workloads get built on top of this. So today we'll talk a little bit about app development, which we think is going to leverage Unistore at its core for many transactional apps that you might want to build on top of Snowflake. Powering Unistore workloads on Snowflake is a new flagship feature, Hybrid Tables. Hybrid Tables are a new table type that give you fast, high concurrency point operations natively within Snowflake, already alongside the analytical queries and workloads that you already run. What enables this to happen is a new operational row store that Hybrid Tables leverage. It has the same cloud services layer, it has the same query engine, but that storage layer is architecturally quite different from what you might be used to with standard Snowflake tables. Hybrid Tables supports features that we know are critical for many transactional workloads. You get primary keys that enforce uniqueness. You can add additional unique constraints. Hybrid Tables will enforce foreign key relationships with referential integrity constraints. You can also declare additional secondary indexes on attributes that are important for common access paths within your app. Hybrid Tables integrate seamlessly with existing Snowflake tables and features. That sounds lofty. I'll try to make it concrete. You can run an atomic multi-statement transaction across a hybrid table and a standard table. You can join a hybrid table and a standard table, and that join will execute natively within Snowflake's one query engine. No federating it out to a different database. That's all going to be fast and snappy. Again, all within Snowflake. Hybrid Tables will support all of the existing Snowflake features that you know and love. Not all of them necessarily on day one, but we have a roadmap to deliver all of those feature integrations over the course of the coming months. Last, but certainly not least, we really take Snowflake's product principles of abstracting and managing complexity for you, our users, very seriously. And the same applies for Hybrid Tables. They're very easy to use, just like creating and working with standard Snowflake tables, but you add a new hybrid keyword in the beginning of the table definition, as you can see in this little snippet on the right of the screen. And again, we'll handle managing a lot of the complexity and the heavy lifting under the hood, so you don't have to deal with that. Lastly, and I promise this is the last thing before we jump into the demo, I want to briefly touch on timeline. Hybrid Tables are in private preview today. We continue to work with many of our private preview customers very closely to make sure we're delivering an amazing feature that you will love. We're in the final legs of that private preview, and we're going to be bringing it to public preview very soon. I'm really excited to work with you, our broader Snowflake developer community, to get your feedback again very soon. Without further ado, let's jump into a demo. For today's demo, we're going to hop into an example of Tastybytes, Snowflake's fictional food truck business. Today, we're going to look at the Tastybytes food truck driver application, which helps our food truck drivers craft their menus, choose locations to go set up for meal times, manage inventory, and fulfill customer orders. Specifically today, we'll look at the ordering experience, how our food truck drivers receive and fulfill those customer orders. We're going to be in the city of Toronto, where in order to handle the peak lunch rush, because it is a weekday, we're going to have hundreds of truck drivers spread out throughout the city, handling potentially thousands of customer orders during that peak meal rush time. The first thing I'm going to do as a truck driver when I am ready to set up for the lunch rush is I'll go hop over into the orders section of the application. You can see here, I've already got a bunch of orders in my queue. Maybe these are some of my loyalty customers who placed orders ahead of time online, but I can also accept orders directly in my point of sale. Let's take a look at this first order from Francisco. And you can see that Francisco has a $12.75 order. They've ordered the original and also 2 of the Miss Piggy. And as soon as I have this order ready for pickup, I can simply mark it as complete. That'll get reflected in my underlying database. And now we can move on to the next customer order. So this is pretty simple. It's a pretty straightforward application, but we'll talk about what this looks like in each of the layers of the architecture. I'm going to just pull up Brennan's order here really quickly. Let's talk about this screen and what this app looks like under the hood. It has a front end that's built in React. Here, that's running in my local development machine. That front end talks to our back end, which is written in Python and leverages Flask and SQL Alchemy. And under the hood, that back end connects to Snowflake. So Snowflake is the database that powers all of the data and the interactions for this application. Specifically for the order experience, we've chosen to use hybrid tables to power this data model because it gives us the latency that we need for these point lookups and point updates, and also the concurrency to allow our thousands of customers and hundreds of truck drivers to all interact with and update orders all at the same time without running into any contention, gumming up the works. All right, let's take a step through this application one at a time. We'll start at the top and we'll work our way down through the architecture. We're going to go hop into Visual Studio Code and we'll start with the front end. As I mentioned, this is built in React. And this is that order detail view that we were just looking at in the app. The main purpose of this order detail file here is it returns this React view. You'll see that at the top of that view, we have metadata like the truck ID, date, and also the order number. Beneath that, we get all those sub-line items for the order, which really just represents this order detail data here. And again, an order can contain multiple different items because the customer, in this case, had like the ranch and the Miss Piggy. So we'll have those different menu item names, the quantity that's ordered, and also pricing information. The front end retrieves this from the back end using this get order detail endpoint here, where we pass in order ID as the main argument. And then once we're ready to update that order, complete it and get it into the hands of our customer, that hits this update order status method here. And again, we pass order ID as the main argument, and that'll hit the update order details endpoint in our backend. All right, let's take this one layer down, and now let's look at the backend. So this backend is written in Python. It leverages Flask as our web micro framework. That gives us things like routing out of the box. Flask, however, does not come with a native database wrapper or driver. So we're going to use SQL Alchemy as our ORM. And again, SQL Alchemy is going to wrap around Snowflake in this case. We've got this database connection boilerplate here at the top. And then this is where the main business logic starts. So SQL Alchemy we're creating these classes to wrap the core data models that we're using here. So we have this customer loyalty class that wraps the customer loyalty table within Snowflake, menu, which again wraps our menu table in Snowflake. And then we've got these two tables for the order, which are the order header and the order details tables. And those really represent that core order data model that you were looking at in the application before. Now let's get to those endpoints that we saw before in the React app. First, get order details. This is the endpoint that we first hit when we click on that customer order from the queue and bring up the details of that one individual customer order. Again, it receives order ID as the main argument. And then what it does is it filters the order detail table on that order ID column, and it retrieves salient details, including the menu item name for that particular order subline item, unit price, and also the quantity. Pretty simple, straightforward, just a really vanilla point lookup. The one thing I'll note is that we are not looking up the menu item name from the order detail. We're actually getting that menu item name from the menu table, and we're joining that in on this menu item ID. And that's important because as this is a transactional app, we're using a more normalized data model than what you might use in a data warehouse. So it's important that we have that normalized data model and we're joining in the relevant data from each of those tables. When we have our customer order ready, we go again and we click that complete order button. That hits this update order details endpoint. And this is even more straightforward. We basically just filter on order ID, and then we update the order header record with a new order status of completed. So this is a very, very simple point update. But again, it's going to be snappy because we're using a hybrid table under the hood. So now let's go one level deeper and we'll look at this in Snowflake to take a closer look at that data model and some of those database interactions. I'm going to hop into Snowsite here, which is our native web UI for Snowflake. First, let's look at the order header table. So the order header table is a data model that maps one-to-one to those customer order objects that you saw in the queue. When we click on an individual order, that pulls up a single order header record. This is a hybrid table. In order to make it a hybrid table, we simply use this hybrid keyword before the table definition. The order header table includes a bunch of IDs here, order ID, and then it links to our truck location and customer loyalty tables using these other foreign keys right here. And then it has a bunch of important metadata like timestamps, and then also this very important order status attribute, which lets us know, whether the order has been submitted and is in the queue or whether that order has already been completed. Hybrid tables require a primary key, which is different than standard Snowflake tables. And here we have that primary key on order ID. Hybrid tables allow you to declare foreign keys, and we will actually enforce referential integrity constraints on foreign keys between hybrid tables. So here we've used foreign keys to formalize the relationship with the truck table, location table, and customer tables. Lastly, hybrid tables allow secondary indices, and we have added those on order timestamp, order status, and shift. Those are important for some of the access paths in our application, so that makes sure that those screens are nice and responsive. Okay, let's look at the second main table that powers this app, and that's the order detail table. Again, this is a hybrid table. The order detail table, there can be many order detail records for a single order header record. Again, because there can be multiple subline items within a single customer order. Each one of these order detail records will map to a single menu item ID. So if I'm ordering 5 different items from the menu within my order, there will be 5 order detail records for that one order header record. Again, we have a primary key on order detail ID. And again, we're using foreign keys to enforce referential integrity constraints and ensure that we have good data integrity within our application. So that's what the data model looks like. Let's now show this in practice and see some of these features in action. I'm going to hop over into a Snowsite worksheet here. And let's pretend now that I'm a customer and I want to submit an order to a different food truck. Before, I was the food truck driver of truck number 44 when we were looking at the application that was running within the browser. Here we're in Snowsite, and let's pretend that we're submitting an order to truck number 2. I'll go ahead and create this order header record. And that works just fine. Now let's go ahead and create a corresponding order detail record, which represents the menu item that we're ordering. But just to demonstrate foreign keys, I'm going to change this first digit of the order ID foreign key so that it's a mismatch with the order header record that we just created. And you'll notice that that fails. The foreign key constraint is violated, so it doesn't actually let me create this order detail record. This may seem small and obvious, but this is a really important net new capability for Snowflake, so I just wanted you to see it in action. Now, if we change that back so it matches, this will go through just fine. Okay, so we have created our order, and now let's hop into the shoes of the driver of truck number 2. I can see this order in my queue, and I want to fire it up and get it into the hands of my customer. Once it's ready, I want to mark this order as completed so that they know their food is ready for pickup. I'll start by opening a transaction, and then I'll update the status of this order to completed. And I'm going to pause here because this is a great opportunity to talk about locking. Hybrid tables, unlike standard tables, uses row locking for update operations. And this is important. With standard tables, they use table locking for update DMLs. Hybrid tables uses row locking. And the reason this is important is because it allows for concurrent updates on independent records. So when we have an application like this, where we expect random write patterns, different truck drivers and users are updating and operating on different sets of records, they can all do this at the same time without running into any lock contention. So if we think about the state of our system right now, we have an open transaction where we've updated this order ID record. And this transaction holds a lock on that record. But because we use row locking, we can operate on any of the other records in this order header table at the same time without running into any issues. I'm going to actually show this in practice by jumping over into the app again. And we're back on Brennan's order, and we can now just mark that as completed. And that'll go through just fine. So we were able to touch Brennan's record and update it, even though in my open Snowsite session, we still have a lock on this new order that we had submitted for truck number 2. Now, if we go back into Snowsite, we can finally commit this transaction. And again, that goes through just fine. So we were doing concurrent updates to different records, no issues with lock contention. Those all work just fine. Let's summarize what we've just seen here. We logged into our Tastybytes food truck driver app, and we saw orders coming in as they were placed by our customers. We looked at an individual customer order, and we marked it as completed as we were able to cook that food and get it into the hands of our customer. Then we looked at how we built this application. We looked at the front end in React. We looked at the back end, which is written in Python with Flask. And then finally, we jumped into Snowsite and looked at how we leveraged hybrid tables to build the data model for this application, how we used primary keys and foreign keys in order to provide data integrity for this transactional app. Lastly, we looked at how row locking enables hybrid tables to provide the high concurrency point operations that are needed for this application in order to allow different food truck drivers and customers to all be operating on different customer orders at the same time without running into any contention. This is just one example of a lightweight transactional app that you can build with hybrid tables at its core. But we've been working with private preview customers on a wide variety of use cases, from Siemens, who is using hybrid tables for managing the state and configuration of their data ingestion workflows, to William Hill, who's using hybrid tables to serve data with low latency in order to serve the promotion treatments through their web and mobile application. As we turn the corner and we make this feature available for you, our Snowflake developer community, in the public preview coming soon, we're really excited to see how you are able to use hybrid tables to simplify your data architectures and all the creative applications that you're going to build on top of hybrid tables. If you're interested in learning more about the hybrid tables feature and the Unistore workload, please check out the Unistore workload page on the Snowflake website. There's a lot of good content there, and we'll also be updating that with stories about how many more customers are using hybrid tables in the real world to simplify their architectures. Thank you so much for joining me today and learning about hybrid tables. Happy building.